Dictionaries often describe the term physics as the study of matter, energy, and the interaction between the two. So basically, in everyday language, physics tries to determine how things move and why things move the way they do.
How many times have you seen this neat invention? Well, it's called the Newton cradle. The most influential scientist of all time and a key figure in scientific revolution came up with this invention, and his name was Isaac Newton. He created this invention in order to represent the three laws of motion, which he discovered. Today we will just be focusing on the first law of motion. Newton's first law of motion states that if the net external force on an object is zero, the object will remain at rest or continue to move at a constant velocity. Or in other words, things continue to do what they were already doing.
Let's take a look at the first demonstration. Still waiting for something to happen? Well, according to Newton's first law of motion, since there is no external force acting upon the object, which in this case is the cup of tea, it would remain at rest since objects continue to do what they are already doing. The cup of tea initially was at rest and it continues to stay at rest. In order to further expand this idea, we can show the forces acting upon it through the use of the free body diagram. The forces applied on the cup of tea are the normal force and the gravity force. We assume that the mass of the cup was approximately 0.25 kilograms and the gravity acting on the cup of tea was 9.8 newtons per kilogram. Therefore, the force of gravity would be 2.45 newtons downwards, and the normal force acting upon the object would be of an equal magnitude of 2.45 newtons upwards, as the table is exerting a force upwards.
Let's look at another example where a similar situation is present. As mentioned before, due to the fact that the candle is experiencing no external force, the object will continue to do what it was already doing. So in this case, it will remain at rest. There's another free body diagram which represents the forces acting upon the candle. Similarly, if the mass of the candle is approximately 2.5 kilograms, and the gravity acting upon it is 9.8 newtons per kilogram. Thus, the forces of gravity acting downwards on the object is 24.5 newtons. Additionally, due to the fact the candle is placed on top of the table, it is exerting a force upwards of an equivalent magnitude.
Now the third demonstration. The law states that if an object experiences a zero external force, then the object will move at a constant velocity. Let's assume that the little race car is moving at 50 kilometers per hour on the highway. According to Newton's law, the object should continue moving at this velocity as long as the forces are balanced. However, due to the fact that the car is traveling on the surface of the road, the force of friction will eventually slow down the speed of the car. On the free body diagram, we can assume that no friction is present. The force of gravity and the normal force cancel each other out, and the car continues to move at a motion of 50 kilometers per hour forward.
Now, the fourth demonstration. The first law of motion is also referred to as the law of inertia. Inertia is the property of matter of an object which allows it to resist the change in motion. In this situation, the blue poker chips experience inertia because they remain at rest as this is what they were already doing. Because the blue poker chips experience inertia, it allows the white poker chip to take the place of the last blue poker chip. The applied force on the white poker chip, which is considered to be the sliding chip, knocks out the bottom blue chip as it takes its place. The momentum of the moving chip is transferred by the one it replaces. The reason why the stack of the blue poker chips don't tumble down is because things at rest want to stay at rest as long as there is no external force or unbalanced
Now,
force.
the last example. As you can see, the egg is at rest while sitting on top of the cardboard tube. There is no external force present on the egg and it remains at rest. Enough force is applied onto the cardboard that the cardboard tube falls across the room. The cardboard tube is used as a support for the egg.
Additionally, there is very little force present at the bottom of the rectangular cardboard and on top of the glass. For a brief moment, the eggs remain at rest while the cardboard tubes are being knocked out, and then the force of gravity acts on the eggs, experience a force downward to the center of the earth.
Furthermore, when the egg experiences this force, it demonstrates the first law of motion. The eggs were falling downwards and would continue to move downwards if the water wouldn't have interrupted the egg's fall. Thus, the water reacts to this force applied as shown by the splashing of the water.